The operations presented in this video are meant to be instructional to ensure quality construction. This video is not intended to provide a comprehensive overview of safety procedures. All parties should ensure that they are familiar with and follow all safety requirements, policies, and procedures that apply to their specific operation. Asphalt paving is a major component of PennDOT's construction program, where hundreds of thousands of tons of asphalt are placed each year. It is not practical to sample every ton of asphalt, so proper sampling procedures and sampling locations are essential to ensuring quality material is being used on our infrastructure. This video will provide a detailed overview on how to properly set up asphalt sampling lots and from where to lift the samples. The key references needed for setting up asphalt sampling locations are Publication 408, Section 413, Publication 2, Project Office Manual, Section C.4.6, and Publication 19, Pennsylvania Test Methods, also known as PTMs, Number 1 for random sampling, Number 729 for pavement cores, and Number 746 for loose box sampling. Asphalt is commonly accepted on a lot-by-lot basis, and each lot will consist of sublots. Each sublot will have a mixture acceptance sample, commonly referred to as a loose box, and a density acceptance sample, commonly referred to as a core. There are certain cases where the mixture acceptance and density acceptance samples will not be loose box and core samples, but these cases are not as common. This video will not be touching on these different acceptance criteria, but Publication 408, Section 413 details how to handle these situations. Projects will usually have multiple job mix formulas, known as JMFs. Asphalt lots are established for each specific JMF. Asphalt lots are in tons, so if a JMF quantity is listed as square yards, it will have to be converted into tons. Project Office Manual, Section C.4.6 details how to compute this conversion. To save time in this video, a detailed overview of this section will not be discussed. However, it is advised to review this section when needed in the field. To start, the sublot size for each JMF must be calculated. A normal lot size is 2,500 tons, with 5 500-ton sublots. This means that any JMF with quantities greater than 2,500 tons will have a 500-ton sublot size. For JMFs with quantities greater than 500 tons but less than 2,500 tons, the lot will be divided into 5 equal sublots. For instance, a JMF with a 2,000-ton quantity will have 5 400-ton sublots. For JMFs with quantities less than 500 tons and the density is deemed critical, the lot will be divided into 3 equal sublots for core locations. However, the mixture acceptance will be based off of certification, and no loose box samples will be obtained. It is important to note that once the sublot size for each JMF is established, it does not ever change throughout the duration of the project. After the sublot size is determined, the sampling location for the loose box and core within each sublot must be calculated. To calculate this, PTM number 1 is used to ensure sampling locations are selected in an unbiased manner. To begin, select a random number between 1 and 100. Use that number as the starting point for the lot and use consecutive numbers after for each sublot. In this example, the number 15 is used, and we will assume that there are 5 sublots. Therefore, numbers 15 to 19 are the random numbers for the lot. For new lots, it is allowable to continue using consecutive numbers from the originally established random number, or a new random number may be chosen for the new lot and consecutive numbers used for the sublots within that lot. Different random starting numbers should be used when determining loose box locations and core locations. Multiply the x value of the random number by the sublot size to determine the portion of each sublot to lift a sample. In this example, after 295 tons of the sublot has been placed, the sample would be lifted. For determining the location across the paving lane for obtaining a loose box sample, simply multiply the paving lane width by the y value of the random number. For instance, using random number 15 on a 12-foot paving lane would result in 8.16 feet. The random number used will also indicate which edge to measure from in the direction of paving. If L is indicated, measure from the left edge. If R is indicated, measure from the right edge. In this example, we would take the loose box 8.16 feet from the right edge of the lane. However, for core sample locations across the paving lane, PTM 729 is followed. PTM 729 indicates to subtract 1 foot from each edge of the paving lane to determine the testable sampling width. So, for a 12-foot paving lane, the testable sampling width would be 10 feet. Then multiply the testable sampling width by the Y component in PTM number 1. And as a final step, add 1 foot to this value to determine the sampling location across the paving lane. This core sample would be lifted 6.8 feet measured from the right edge of pavement. If an obstruction such as a manhole is encountered when attempting to lift the sample in the field, collect the sample 1 foot away from the edge of the obstruction. At this point, we have reviewed lot and sublot sizes, how to determine sampling locations within each sublot, and where across the paving lane to lift each sample. Now, lot readjustments and terminated lots will be reviewed. When operational conditions or project size dictate, readjustments of lots will be made using Table D, which is located in Section 413 of Publication 408. Table D will typically only be used for a JMF's last lot or when a lot is terminated. As previously mentioned, a typical lot size is 5 sublots. However, if a final lot has 2 sublots or fewer, it will be combined with the previous lot. This will result in one lot potentially having up to 7 sublots. If a final lot has 3 to 5 sublots, it will be a new standalone lot. While lot sizes will typically be between 3 to 7 sublots, partially completed lots of 1 to 2 sublots can be independently evaluated when conditions occur where they cannot be combined with the most recently completed lot. A sublot will only be considered complete if there is both a loose box and a core sample. For example, if 3 cores and 2 loose box samples are lifted in the final lot, there would only be 2 complete sublots, and the 3rd core sample would be discarded because it does not have a companion loose box with it. Let's go over a quick example to help tie everything together. A JMF on a project has a total quantity of 8,750 tons. Since 8,750 tons is greater than a standard lot size of 2,500 tons, a 500-ton sublot size is established. In this scenario, there would be 3 standard lot sizes of 2,500 tons. However, what should be done with the remaining 1,250 tons? Remember, a 500-ton sublot size has already been established. Therefore, there may be up to a maximum of 3 additional sublots based on this remaining quantity of 1,250 tons. As a first scenario, PTM number 1 is used to randomly select a number for the start of the lot. Remember that different random numbers should be used for loose box and core starting lot locations. After completing the calculations, 3 loose boxes would be obtained. However, only 2 core samples would be obtained due to the 3rd core location being outside of the 1,250-ton range. Because the 3rd loose box does not have a companion core, the 3rd loose box should be discarded, which would result in a total of 2 completed sublots for the remaining 1,250 tons. In this second scenario, the same process is completed using different PTM number 1 random numbers. However, after completing the calculations, there are 3 loose boxes and 3 cores obtained. In this case, there would be 3 completed sublots for the remaining 1,250 tons. With either scenario, Table D must be used to determine what to do with the samples. Since the remaining quantity of 1,250 tons is between 1,000 tons and 1,500 tons, 2 options are available. For the first scenario, where there were 2 completed sublots, Table D indicates to combine these 2 sublots with the previous lot, which would result in 3 total lots. Lots 1 and 2 would have 5 sublots, and Lot 3 would have 7 sublots. For the second scenario, where there were 3 completed sublots, Table D indicates create a new lot with these 3 sublots, which would result in 4 total lots. Lots 1, 2, and 3 would have 5 sublots, and Lot 4 would have 3 sublots. Lots will be ended if there is a work stoppage of 5 days or more, and also may be terminated at the contractor's request. Work stoppages may come as a result of weather, scheduling delays, and issues with the material and/or paving operation. If a lot is ended from a 5-day stoppage of work, adjust that lot size as specified in Table D. Afterwards, begin a new lot when work commences. However, lots terminated by a contractor's request do not follow Table D. Reference Publication 408, Section 413.3 H2.A for additional details. To conclude, setting up asphalt sampling lots and knowing how to readjust lots as field conditions dictate can be tedious and a bit confusing. It is important to read and become familiar with the referenced material presented throughout this training. Correctly sampling asphalt is critical for both a quality product and contractor payment. It is always recommended to seek clarification or help from experienced managers, inspectors, and QA representatives if you are unsure how to handle the many different situations that may arise on the project. A special thank you and acknowledgement to the following contractors for their cooperation: